Round of applause for the panel, please. We'd also like to thank our co-partners, Khaitan & Co., Kaizen and Hughes System. Let's now move to our next session, and this is a very special one. It's now time for the C.K. Prahalad Memorial Lecture. This session is powered by Deloitte, so we'd like to thank them for their continuous support. I would like to take this opportunity to invite on stage Mr. Atul Dhawan, partner Deloitte, to take the proceedings forward. Please, sir.
Thank you, and delegates, welcome to the C.K. Prahalad Memorial Lecture for 2024. Just to help you set the context on why we do this, why we have a memorial lecture in the honor of C.K. Prahalad, TiE has had its vision derived from C.K. Prahalad's teachings and his concepts that he put out, especially relating to the startup and the entrepreneurship community. You know, he left behind a very rich legacy of strategic insights and innovative concepts, which concepts remain as important today as they were when they were first written up some many years ago. He has valuable lessons for established businesses, for the startup community, for everybody. He introduced us to management concepts and tools that we all continue to keep in mind as we go down our entrepreneurship or business journeys. Let me take some of those concepts that he introduced us today to us and how they remain relevant today. He introduced us to the concept of core competence that emphasized that organizations must focus on their unique strengths and capabilities. We do the same today. We do the same in the startup community. You focus on what is your strength and what is it that you must focus on. He taught us the concept of strategic intent, where again you define your long-term vision and go beyond just short-term goals. You have a compelling strategic intent, a compelling strategy, and your decision-making then needs to align to that. Again, that's a topic that remains relevant even today. But the most groundbreaking of ideas that he gave us, and it's something again we address in the entrepreneurship and startup ecosystem today, was the bottom of the pyramid. He showed us the light that at the bottom of the pyramid, when you find solutions to the problems faced there is a fortune waiting to be made. In fact, even in the startup program for the country today, the Prime Minister also says that you find solutions to problems in India, and then you can go out and take that to 9/10 of humanity. It is the opportunity for you to look at scaling your businesses when you're in your startup phase. And that again goes to what he used to say, that you think beyond borders. Globalize, and globalization must be an objective that you should keep in your mind. And we've seen over time that these are ideas that have not remained theoretical. He actually demonstrated them by working in different companies and ensured that these are practical concepts that transformed businesses. Those are not just the only concepts that Prahalad introduced us to. He taught us about inclusive business models, looking after the underprivileged, looking after taking our social responsibility. And it is, I think, important for us, and that's one of the reasons at TiE we have this memorial lecture to honor C.K. Prahalad. We honor his memory by pledging to carry forward his legacy of the innovation, inclusivity, and that social responsibility. And he was also very forward-looking. He taught us about looking at ideas and solutions that go beyond the established limits. And I think that is something that we will do today. We will talk about space, and I'm going to invite my colleague Vinod Sood to come and talk about space. We all remember the line from a famous TV serial, which is The Final Frontier. I'm not sure if that's going to be the final frontier, but we'll see more as we go along. But I'm going to request Vinod to come and share with me and introduce our guest today and talk to you about the potential in the space industry that opens up, again, business opportunities for us. Vinod, could I have you here, please?
So, good afternoon, friends. So, while deliberating about who we should invite as a speaker for this year's C.K. Prahalad Memorial Lecture, Geetika, Atul, and myself thought that it will be a good idea to have a women leader as our speaker, given that this edition of TiEcon coincided with the Women's Day, which we celebrated yesterday. Now, Atul talked about the space sector, and if you see, last year was a stellar year for the Indian space sector with successful launch of the Gaganyaan mission, the Aditya L1 mission, launch of private satellites for international operators like OneWeb, and a large number of startups emerging from India in the space sector. So it was in the fitness of things that we should invite a women scientist from India's premier research organization, ISRO, as our speaker. So it is my pleasure to welcome Mr. Shalini Gangele, Deputy Head of MSDW Division, Space Applications Center, ISRO Ahmedabad. But before I request Shalini to give his address, because Atul requested me to talk about the space sector, let me just spend a couple of minutes. So the space sector, it is predicted, is going to be a 13 to 15 billion opportunity by 2025 in India. And what we have seen in the last few years is that a number of startups have emerged, and you would have heard names like Agnikul, Skyroot, Dhruva Space, Bellatrix. These are some of the startups which have come up in the space sector. When we talk about space sector, typically what we think about is a rocket and a satellite. But let me just take a minute in terms of telling you folks what space sector means. So a space sector has three components: the user segment, the ground segment, and the space segment. And the space segment is the one which consists of the satellites and the launch vehicles. And when I say launch vehicles, basically rockets. And if you look at launch vehicles, we have different kinds of launch vehicles. There are single-use launch vehicles, and now we also have reusable launch vehicles, which is what Starlink is pioneering. If we talk about satellites, you can divide satellites into two categories. One is in terms of the orbit. So you would have heard about geostationary Earth orbit satellites, medium Earth orbit satellites, and the low Earth orbit satellites. But then there is other segmentation which you can do, which is in terms of what is the use of the satellite. So you have communication satellites, you have navigation satellites, you have Earth observation and mapping satellites, and you have astronomy and weather satellites. So this is as per the user. And if we talk about the user segment, then it consists of the satellite terminals. You would have heard about a term called VSATs, very small aperture terminals. You have large terminals, and now you also have very small terminals like your mobile phones. So this, in nutshell, will give you an idea about when we say space segment. So now let me quickly introduce Ms. Shalini. Shalini was born in Ratlam, MP, and she received her BE degree in Electronics and Communications Engineering in 2002 from North Gujarat University. She is a university topper and a gold medalist of her batch. She also holds a ME degree in Communication Systems Engineering from LD College of Engineering, Ahmedabad. And she also topped her ME course and received the Institution of Engineers Gold Medal for ME. She joined the Space Application Center ISRO Ahmedabad in the year 2003 and since then is working in the Digital Systems Group of Microwave Remote Sensing area. She is currently the Deputy Head of the Microwave Sensors Data Acquisition and Waveform Generation Division. She has a rich experience of 20 plus years working as a scientist engineer and has contributed extensively towards design and realization of digital systems for ISRO's various spaceborne Earth observation satellites like RISAT series of payloads, Scatterometer series of observation satellites, NASA ISRO synthetic aperture radar, SweepSAR mission, which is a joint collaboration project between NASA and ISRO, and the Global Navigation Satellite System, GNSS. She also has worked in design and realization of radars for ISRO's Chandrayaan mission, as well as several airborne platform-based missions. Currently, she is working for the design of miniaturized and advanced digital beamforming systems for follow-on synthetic aperture radar payloads, as well as millimeter wave hyperspectral sounder for upcoming G20 satellite mission for environment and climate observation. Her areas of interest include design and development of real-time data acquisition and onboard digital signal processing systems based on FPGA algorithms. She has authored more than 30 technical papers and presented at various national and international conferences. She has been honored with the ISRO Young Scientist Merit Award for the year 2011. She also has received the Team Excellence ISRO Award, and recently at the Republic Day ceremony, Prime Minister Modi had invited her along with few other women scientists as his personal guest. So over to Shalini.
Thank you, Vinodji, Atulji, and Gitika ji for introducing me and inviting me here at the TiE. This forum is totally new for me. So far, I have given talks in a very, very technical forums, and this forum of startups, yes, it's totally new. Since yesterday, I have been witnessing the events that is happening over here, and I can see lot of ideas and innovations coming up. And that's a very big step, a significant step towards the Amrit Kal, the 2047 vision that Prime Minister, Honorable Prime Minister, Shri Narendra Modi has kept. And I can see a lot of innovations coming up in SDG side, sustainable development, so that is very good. Surprisingly, very few in the space sector. That is what I couldn't hear anything from the space sector, but yes, we are looking forward for Make in India space technologies as well. So if somebody can come up with it, that's welcome. We are looking forward for the technologies that are being developed here. Okay, coming to my topic. Okay, coming to my topic, I was asked to give a talk here. So I thought rather than navigating through my journey, I should focus on the journey of what ISRO has been through. Its journey from its origin to expansion. This is 70 years of journey in ISRO. So space is something, I guess almost everyone sitting here in our childhood, sometimes or the other, we have been fantasizing about the space. We are very curious for learning what's the space. Okay. Learning something about the space, and we are curious to know the galaxy, the planets, and all about that. But let me tell you, The space is harsh. The environment, the space is, it's not forgiving. It's unforgiving environment with lot of radiations, ionizing radiations, and there are a lot of challenges when we talk about something like space. Like a gravity, the very force that keeps us grounded here, that is what is stopping something to send there. Satellites, when we are sending to the space, lot of tons of fuel is required to move out of the orbit. So the gravity is big, the thing that has to be taken care of. And the distance between celestial objects is very, very large. That is also playing a role in designing the satellites mission planning. Space debris, there are lot of debris, asteroids, meteorites, they are there that collide with the satellites, or are like it can harm our astronauts or satellites. So that has to be taken care of. And the navigation, like we have GPS, IRNSS here to navigate. We can locate our position using those technologies. But satellites need to know their position also. So something called universal position system is there that has been designed. Of course, the effects on astronauts are also not very, like they are also radiation, microgravity, lifestyle changes. They have to go through all this psychological effects, which are long term. Having said that, there are the ways to overcome these challenges. There were very few of the challenges. There are much more than that. But there are the ways to overcome this. And now the future opportunities, there is a lot of future opportunities for youth, young scientists and researchers with what is known as space architecture concept. Space architecture is basically the practice and theory of designing and building a space architecture where we look forward for building the habitable architecture on other planets. So that is globally, this has been a concept that everyone is looking forward to and working towards that direction. So when it all started, 1957 was the year when globally in the world, first satellite was launched, that was of Soviet Union. It's the Sputnik 1. So with that, that was the first satellite which during which the other countries also started thinking about that this is possible. So how foundations, so East India too started thinking about that in that direction. So with the Dr. Sarabhai, who is also known as the father of Indian space program, Dr. Sarabhai came up with the idea. Initially, when he was doing PhD, and after coming from abroad, he started physical research laboratory in year 1947 in Ahmedabad for continuing his research work. And that was the step that he took in the first step towards joining into the space sector. And then he, along with the help of Dr. Baba and Dr. C.V. Raman, S.S. Bhatnagar, these are the pioneers. With the help of that, in COSPAR, Indian National Committee for Space Research was founded in year 1962, which was later transformed into in year 1969 into the ISRO, Indian Space Research Organization. Later Department of Space, that is DOS, was formed in 1972, and then the ISRO was part of, since then ISRO is a part of DOS. So how it started, Indian Space Program, a humble beginning. So when this thought came up in Dr. Sarabhai, so Dr. Sarabhai's vision was to use the space technologies for betterment of humankind. That's when this was started, and he caught the attention of one of the churches in Thiruvananthapuram, in outskirts of Thiruvananthapuram, that is St. Mary's Church. The location of church was what that caught his attention. It was near to sea, and plus it was at the equatorial magnitude of equator, so magnetic equator center of. So that caught his attention, and that is where the first design lab was started in year 1963. First sounding rocket was launched from there. That church is now Vikram Sarabhai Space Center, and it's a space museum, but that was later transformed into Vikram Sarabhai Space Center in Thiruvananthapuram. So this is the shown beginning days of ISRO is shown here, where rockets were taken on the bicycle, and the satellites were taken on the bullock carts. So basically, the Indian space program, the three distinct elements of the space program, or when ISRO started working on, where one of those was the transport vehicles, that is transportation system, that is the launch vehicle program, then space infrastructure, that is designing and building of the satellites, and third is space applications, that is usage of data and the building of ground stations and receivers for that. These are the leaders of ISRO since the beginning. Till now, Shri S. Somnath, Dr. S. Somnath is the chairman of current, and these are the visionaries, and under the guidance of whom ISRO has taken a leap from taking the rockets on bicycle to the landing on moon. First few experiments on which ISRO has a very limited resource when it was started, but the dream was big on this pioneers. So initially it started with the SITE experiment. SITE is it's a television experiment that was taken up in the rural areas in the year 1975. And very same year, the first satellite of India was built up, that is the Aryabhatta, and named after the Indian astronomer and mathematician. Aryabhatta was launched by the Soviet Union rocket. And in parallel, launch vehicle technologies were research started on that also. So SLV-3 satellite was the first launch vehicle that was formulated and built. Dr. APJ Abdul Kalam was the project director of SLV-3 launch vehicle. And then India never looked behind after that, so looked back after that. And this is the journey of launch vehicle, where it started with SLV-3, augmented it with ASLV, then the PSLV, Polar Satellite Launch Vehicle, which is currently the workhorse of ISRO. More than 50 plus satellites have been launched so far. PSLV has taken Chandrayaan-1 to moon. It has broken the record of launching 104 satellites in one go. And then GSLV, the launch vehicle capability of taking the satellites to the geostationary orbits, as GSLV was come up with that, augmented for that. And now GSLV has been modified for much awaited the Gaganyaan mission, that is human spaceflight mission. So human spaceflight mission Gaganyaan will take the crew module, a crew of 3 members, and the complete GSLV is being modified to for safe re-entry of it into the sea and bringing the astronauts back. And then this is SSLV is the recent addition to the launch vehicle technology. It is for a low cost. It is for the launching of microsatellites and nanosatellites. This is basically for many startups that are coming up for the satellite launch facilities to be used. So SSLV has a very low turnaround time, and with that intention, this was being built up. It will have many launches per year. And now a very ambitious reusable launch vehicle technology work is going on that. That is it is a very complex technology. It's fusion of aircraft and rocket technology. A lot of tests are being done, and it's still the work is in progress for the RLVTD to be operational. Coming to the satellite programs of ISRO, yes, ISRO is into the building of communication satellites, navigation satellites, Earth observation satellites. This is round-the-year job of building so many satellites, and these are being used for many applications like broadband, 5G, remote sensing applications like disaster management, the Earth observation satellites, navigation for the navigation, like our own Indian regional remote sensing satellites we are having, that is named as NAVIC. It is a constellation of satellites for location. We have Earth observation satellites that is being used for observing the Earth, and this Earth observation satellites are same remote sensing satellites that are being used for planetary missions as well. However, planetary missions imposes altogether different challenges, where weight, volume, and power is the challenge that has to be taken care of, because going into the deep space requires quite a lot of tons of fuel, and the more the fuel, more the cost is added to it. So that is why that has to be miniaturized. So that is the challenge that is into building the planetary missions. So India came up with the formulation of idea of building the going into the deep space. So Chandrayaan-1 became the first such mission that into its ambitious program. And then Chandrayaan-2 was launched in 2015, and then And as you can see, Moon is the nearest object. It is the natural satellite of Earth. It is the nearest object. Still, the distance between Earth and Moon is 384,000 kilometers, and that has to be covered. So this was India's first mission where this mission planning, these technologies were required. The instruments, if we talk about Moon, it is very, very different to that of the Earth. The gravity is 1/6 of that on the Earth. There is no atmosphere at all on the Moon. The geology of the Moon, lunar geology, is quite different. The bathymetry features are very different. Since in the absence of atmosphere, there is nothing, what we call as soil erosion. So all the activities there are due to the volcanic activities. So in order to study that, the globally instruments were selected, and ISRO selected 11 instruments worldwide. As a technology that could be taken on Chandrayaan-1 mission. So this mission was India's. However, the instruments sitting there were all taken from the different space agencies across India. As shown here, the astronaut was jumping there because of the gravity. We cannot walk there, the 1/6 of gravity on the Moon. Whatever step is taken, it's always jumping there. So Chandrayaan-1 became the first mission to be launched in year 2008. It got the discovery of water. It led to the discovery of water on Moon. And globally now, after Chandrayaan-1, everyone is interested in revitalizing the interest on Moon. A lot of Moon missions have been taken up worldwide now after Chandrayaan-1 discovered the Moon. Also, new technologies were developed as part of Chandrayaan-1 mission, like the deep space antennas, 18-meter and 32-meter antennas, as a deep space network was developed in order to have communication with the spacecraft therein. In 2008 November, then the first leap that was taken was when Chandrayaan-1 dropped down the lunar impact probe with the Indian flag on it, and that was on 14 November 2008, as shown in the image here. Shackleton crater was the name of that crater. So, post Chandrayaan-1 in 2008, Chandrayaan-2 was formulated. However, Chandrayaan-1 was taking only the orbiter. Now, ISRO thought of taking the developing orbiter, lander, as well as the rover. So that was what Chandrayaan-2 started with. However, ISRO was not having lander technology at that time. So what was thought of is the Russians were having that technology. So Russia will give its lander and India will have its own orbiter, and that is collaboration was happening. However, something didn't work out during that time frame, and then ISRO took it to itself, the challenge to itself, that it will be developing lander and rover module by itself. That is how Chandrayaan-2 got delayed. And in between, the Mars mission was taken up, so the visit to Red Planet therein started. Here, if you see, Mars is the next planet to the Earth, and so it is seen as the next habitable planet after the Earth. And the technologies which we are developing as a habitable planet is, since when we are living on the Earth, this should be explored. So that is what is the new thing that is being taken up. So Mars mission was also very ambitious. Launching into the planetary missions, there is an opportunity windows which has to be taken care of. So Mars mission, we only got 18 months to complete the development work. So the Chandrayaan-2 and Chandrayaan-1 had some of the hardware that were being used for. And with that, very fast Mars mission was developed in 18 months with very low cost. PSLV launcher was taken, and finally it launched in November 2013. And after the 10 months of journey, it entered into the Martian orbit. Many countries earlier tried, but very few succeeded in its In fact, India is the first country to have succeeded that in its maiden attempt. So it was the record. These are the findings of Mars mission, very beautiful images it has come up with, and there is an atlas that has been released for instruments were working till 2002. So these data will be utilized by scientists and for the next Mars Orbiter 2 mission. So after that, there is no looking back again. Chandrayaan 2, Chandrayaan 3, Chandrayaan 3, as you all know. Chandrayaan 3 is a great success. India made a history landing in Chandrayaan 3. Chandrayaan 2, in Chandrayaan 2 also orbiter, lander and rover were taken up. However, orbiter is a great success. Still, our instruments on orbiter are still working. It is giving a very beautiful, very high resolution images. And in fact, these images are used for they are used for landing site detection of the Chandrayaan 3. So in Chandrayaan 3 orbiter, Chandrayaan 3 took up a lander and rover, and India successfully landed on the moon. The landing site is being named as a Shiv Shakti point. Shiv is like humanitarian ambitions, and Shakti means how we are achieving those ambitions. So this was term given as a Shiv Shakti point. And also Shiv Shakti determines the synergy with which men and women work together. So it is a very significant, and the 23rd August, on which the day on which India landed, is named as a National Space Day. So post Chandrayaan 3, Aditya 1 was taken. It is India's first solar observatory. It took 120 days almost to reach there, and it is now it is 15 lakh kilometers away and studying the sun. So this is all about the ISRO's achievements, and still it's going on. Work is going on. Talking about the failures, coming back about the failures, Chandrayaan 3, when we talk about design changes from Chandrayaan 2 to Chandrayaan 3, a lot modifications has been done. So it was taken in a positive spirit. We don't call it as a mission failure. However, we have learned from that failure. The design was completely ruggedized. A lot of reviews has been taken. It has been done after that. A lot of design changes has been done. Ruggedization of the rover and lander technologies has been done. So work culture of ISRO, if we say, yes, we learn from failures. There is an organized, dedicated, and cumulative team efforts that's been going on. Thorough open review mechanism is there. Attention to small details is being given. Risk management is being considered about. There is a strong system of quality, reliability, and safety into it, and freedom to innovate. Because once we go on space, there is no second attempt. It has to work, that's it. Otherwise, it's a failure. So we have to take it in that way. Lot of reviews, simulations, design, testing, all has to happen here. Talking about the women empowerment in this technology, yes, I can see a lot of women here as a startup, as an entrepreneurs. So ISRO is also not behind. We have, although the workforce is currently only about 20% only, but women scientists have shown the all the efforts that that other sectors are also showing, like focus, determination, patience, and perseverance that is required. Women, of course, having multitasking capability, so they are handling both family life balance as well as the research side. And then there is a systematic approach with which women works around, so that gives an added advantage. Women are now in leadership roles as well, and project designates. Women are breaking the stereotypes by working 18 hours a day with the same male colleagues, and they are working on weekends as well. This shows the photographs of celebration of women after Mars mission and Chandrayaan 3. Prime Minister addressed the women scientists in the forum. The upcoming missions, they are at various stages of project approvals. Gaganyaan, it's a much awaited human next step ahead for ISRO, where a crew will be taken for human spaceflight mission. Other satellites upcoming are Chandrayaan 4, which will bring the lunar sample, Mars orbiter mission 2, Mangalyaan, Venus orbiter mission, LUPEX, it's a joint lunar exploration mission between the ISRO and JAXA. So many more are in pipeline, a lot more than that. These are the planetary missions that are gaining attention. This is my small journey, 2 decades of journey, which I'm showcasing here. Such type of jobs, when we are working in a government setup, it's not very rewarding, or it's not very lucrative like other private sectors. But yeah, a small step, and the passion with which we are working definitely keeps us moving. Some of the awards and rewards, or this I got through witnessing the launch and all. Thank you for your kind attention. I hope I have not taken much time.
Thank you, Shalini. We'll request you to stay on stage, please. I'll also request Atul and Vinod to please join us back on stage. Please, sir. I'll request Gitika to please offer a small token of appreciation to all our esteemed guests. We'd also like to thank our co-partners for this session, MongoDB, Arctic Invent, Startup Steroid, and TiE Toronto. Thank you once